Volume and surface area of prisms. Find the volume and surface area of the rectangular prism shown below. Now before I do that, I'm just going to say a word in general about prisms. A prism is a shape which has the same cross-section along its length. That cross-section should also be a polygon, so strictly speaking, a cylinder isn't a prism, although it shares a lot in common with prisms. Now with a rectangular prism, any of the ends or any of the faces could be taken as the cross-section. For example, we could take this one as the cross-section, and then if we slice along here, we would always see this 3 by 4 rectangle, which tells us it's a prism. Now the volume for a prism is always the cross-sectional area multiplied by the length, and if we've chosen the 3 by 4 to be the cross-section, then the cross-sectional area is 3 times 4, and then we multiply it by the 15. Now in the case of the rectangular prism, you can see it wouldn't matter which one we chose, we'd end up multiplying the same 3 numbers together. So what we have there is 12 times 15, and that gives us 180. So we can say 180, and in this case all the lengths are centimetres, so centimetres cubed. Now for the surface area, one way of doing this is to draw the net of the shape. You don't have to do that. I'm going to do this one by drawing the net because quite often you're asked to do that in questions, but it's not actually necessary. So if we think about this rectangle here, this one is 15 by 3. So we'll have this one here which is 15 by 3. Then the one along the top here would be 15 by 4. So that's going to be a 4. And then on the back we'll have a 15 by 3. And then underneath a 15 by 4. And then we need the flaps on the side here, so if I choose to put the flap on this one, remember these rectangles are 3 by 4, so if that's 4, that's going to be 3, and we'll put this one over here as well. And then the surface area is just going to be the area of all these rectangles added together. So this one would be 12, this one's 12 as well, 3 15s, so that's 45, 4 15s, 60, so this would be 45, and this one would be 60 as well. And if we bring in the calculator, we just need to add those up. So we've got 12, add 12, add 45 and 45 is 90, 60 and 60 is 120, and that's 234. So 234 centimetres squared. Now as I said, it's not actually necessary to draw the net. You could just look at the various rectangles that make up the shape and add up the areas of those rectangles. To me, drawing the net just adds in the extra complexity of actually drawing the net. However, you are quite often asked to do this in questions, and that's why I did it that way. Now we want to find the volume and surface area of the triangular prism shown below. So the volume is once again cross-sectional area multiplied by length. This time the cross-section has to be the triangle. If we sliced it along these lines, we just get a rectangle that's getting smaller, so that wouldn't show us a prism type structure. But if we slice along this way, we'd always have this triangle at the end. So the triangle has a base of 4 and a height of 3, so its cross-section is a half times 4 times 3, and the length is 8. So that's 2 times 3, 6 times 8 is 48, so that's 48 centimetres cubed. Now for the surface area, let's just think about the surfaces that we need. We have two triangular ends which are 4 by 3. So the areas of those are half times 4 times 3 gives us 6 centimeters squared, and of course we've got two of those, one at this end, one at the other end. On the back here would be a rectangle, and the height of the rectangle is 3 and the width is 8. So we've got a rectangle 3 by 8, and so the area of that would be 24 centimeters squared. On the bottom we've got a rectangle that's 4 by 8. So that makes it 32 centimeters squared. Now in order to work out this front rectangle we need this length. And we can use Pythagoras' theorem for that, because we've got a right-angled triangle. This is the hypotenuse, so it's going to be the square root of 3 squared plus 4 squared, which is the root of 9 add 16, root 25, which is 5. So this length is 5 centimeters, and so we've got another rectangle which is 5 by 8, giving us 40 centimeters squared. So if we just bring in the calculator, what do we have? We have got 6, and we've got 2 of those, and then we're adding 24, add 32, add 40, and that gives us 108. So this one is 108, and that would be in centimeters squared.